Hi, everyone. Thanks for joining our presentation. My name is Konrad Czarnota, and together with Piotr Falkiewicz, we will tell you about the lessons learned from browser use and computer use. We both work as senior machine learning engineers at DeepSense AI and had recently a chance to give those frameworks a try at a commercial project and in internal use. So without further ado, let's start. Here's a short agenda. So first, I will talk about the browser use. We will have the introduction, a demo, and some set of practical tips. Then I will pass the voice to Piotr, and he will tell you more about the computer use, starting with the introduction, follow up with challenges and tips. We will have a demo, and at the end, we will have a benchmark. So first of all, browser use. What is it? This is an open source framework that connects AI agents with the browsers. With this, agent can basically click, type something into forms, it can navigate through pages. So basically, it mimics human-like interactions. With that, you can tell it to do something for you, and there is a high chance that it will succeed at doing so. It has an ability to understand the web page via HTML structure extraction. Plus, optionally, you can include a screenshot of your web browser. And based on those information, agent can decide what action to take to meet the final goal. The very important thing is that it's very easy to set up and start using. I was personally surprised at the first time when I tried it. You basically need to install it and provide a prompt, and that's basically it, and it should work fine. On the right side, on the bottom, you can see the star history from GitHub. This framework is very popular. They were able to hit over 50K stars in just a few months. So that's pretty impressive. Let's start with the use cases. So what you can do with this browser use framework. There are multiple choices. This is just a selection from the examples on their web page. You can do the shopping. You can ask the agent to buy things for you. You just need to provide a list of groceries. You can do different kinds of automatization, like adding LinkedIn followers to leads in Salesforce. You can ask it to apply for jobs. You can provide it with your CV and ask it to find relevant ML jobs and then apply to them. You can make it do the writing and then export it to a PDF file. Or you can do all kinds of search with given constraints, like models with a license and sorted by the number of likes. Those are very general use cases. Our case that we did on a commercial project was more specific, and that was an agent following instructions. So basically, our client have a set of instructions on how to perform different processes in their management system. And those were written for humans. And of course, humans were doing it, but it was taking a lot of time, and it was kind of mundane work. So it's a good case for automatization. So the idea was to provide those instructions to the agent. The agent was supposed to follow them, perform the steps, and save the actions along the way, creating the so-called trajectory. After that, we can basically replay this trajectory using the playwright. This is a framework that's allow for programmatic access to the web browser. And with that, you won't need a human to do this ever again. You just can start this script, and the only missing part is the parameterization. So if you run it first for a person X, then you should be able to run it for a person Y. And that's what we added, and it worked pretty well. There were some problematic cases, and I will tell you about them more later. but right now we'll focus on a demo. So this is a confidential project, so I'm not able to share the actual work with you. But during the work on this project, we created a contribution to the original browser use repository with a few features. The one that I will show you uses the agent to input a number. So default option, the action that was available, it didn't work well because there was a custom JS code doing the checking on an input field. So we needed to simulate the presses of the keyboard instead of like pasting the text into the field. So here's our demo. On the right side, you can see my terminal. There will be the input from the agent, and on the left side, there is the web browser opening. So let's wait for the initialization, and let's pause for a bit. So you can see a lot of colorful bounding boxes on the left side. Those are for the debugging purposes, and they show you what elements the agent can interact with. So basically, it can read the whole page, plus it can interact with a set of elements. On the right side, you can see the output from the agent. So the task here was very simple. Go to the given page, and then input find the city covered by a given zip code. This agent performs the actions in steps, and each step consists of a few, let's say, outputs. The first one is the evaluation. This is, of course, LLM-based evaluation, so you cannot trust it completely. You will find that the agent sometimes will tell you that it did something, but it was not really successful, so you need to provide your own evaluation. That would be the best option. The agent has a memory, so it can write there and it can read from there. So basically, it can interact with it. There is the goal that it wants to achieve. And there is the last action performed. So that was just simply go to the URL. And with that, we can let the agent do its work. It takes a bit because after each action, basically the agent needs to like process what happens and take the next one. Yeah, and basically that's it. The agent was able to successfully input the zip code and find that the city covered by it is the San Francisco. That was a very simple example, but I think it can give you like the high understanding of how the framework works. And I will now move to the graph that will explain it a little bit more. So here actually we have two LLMs. One is responsible for planning, and this planning LLM can be the thinking model. And the second one is responsible for the execution of the action, and this one cannot be a thinking model. Based on the task description that you provide to the agent, the planner uses it to create a high-level, high plan what needs to be done, and it passes it to the executor. And now the goal of the executor is to do one step toward the end goal. It needs to choose an action from all possible options and then assign the needed parameters to this action and pass it to the playwright that interacts with the browser and does the action, basically. This, of course, updates the states, and the whole pipeline, the whole loop can continue. There are a lot of things that you can parameterize here. So the planner can be run each, let's say, 10 steps or even every step. There is a high flexibility in this framework, and you can basically change a lot of things here. So with that, let's move to the practical tips. So I think the most important part from our experiments with the framework, the point number one is that the simpler and static pages work much better. So you can imagine this as having this form on the right bottom side, and it can be very simple, that you can only provide text input there. That would be very easy and static, but you can have the inputs that, for example, are expandable. So you type something, it shows you like the hints, and then you can click on something and choose. And this actually makes it harder for this agents to interact with pages like that. So the simpler there are, the less buttons there are, then there is higher probability that the agent will succeed. The next thing is with the way the page is built. So you can imagine this submit button on the right top side. It can be expressed in HTML either in a simple form like a button and like submit, the very easy tags, or it can be generated via some framework, and it can be a div with a class that is basically some numbers or letters. And with that, of course, we had the second case, the harder one. And our LLM was hallucinating a lot in this scenario. So it's better to provide the screenshots as well to the model. So not only the HTML structure, but screenshots as well. But still, you cannot expect it to work if you don't have like additional context. So it would be good, for example, to this house number input field to have some kind of a label. So the model knows that this is the field that it should put something inside. The next thing is about the actions. So by default, per step, the model can decide to do up to like 10 actions or something like that. So you can imagine that it wants to put the street, house number, and apartment in one go. And if your page is dynamic, so something will pop up once you enter the street, it might obscure the apartment. And the agent, from our experience, it wouldn't tell you that something is wrong, but it will put this apartment number into another empty field. So for example, into the zip code. So this is something that you need to keep in mind, and we encourage you to do one action per step, and this is more reliable in our opinion. Let's now move to the practical tips number 2. So the thinking model was an overkill in our specific case. So it was more like following instructions. But I guess in the generic cases, like applying to CVs or applying to jobs with CV or things like that, I guess it's always a good idea to try and start with it. The GPT-4o was what worked best for us. I think I've read that right now people say 4.1 is the best instruction following model. So it might be a good idea to give it a try. It was not available when we were doing the project. And the mini version of GPT-4o struggled a lot. It was not able to navigate through pages. It gets stuck at the landing page. Except for that, as I mentioned, the deterministic evaluation is needed in our understanding. So the idea for that might be to create a loop in which you first run the agent, then you have the deterministic way of checking if the state of the web page changed. You can use Playwright for that, for example. And after that, you need to reset the state of the web page, so it's back to the, let's say, 0.0. With that, you will know that if the agent did what it was supposed to do, because the models tend to be very overconfident. They don't like do what they are supposed to do and tell that everything's fine and ready. The second thing that's helpful, in our opinion, is creating an additional metric, like a helper one, that checks if a list of performed actions is similar to the list of actions that you expect. This way, you can have like, let's say, a percentage of how far the agent went from like doing the task. So it can get stuck at the very beginning or like close to the end, and that's a different story. it might need different changes in the prompt, for example, to see what's going on. And here's the quick summary of the first part from the browser use. This is a very useful tool. It gives you the possibility to use the agents in a browser with a minimal setup. It is actively developed. Not everything there might work yet, but it's usually easy to adjust the code and fix it yourself. And with a common sense usage, you can accomplish pretty complicated tasks. I was surprised to see what those agents can do. And I encourage you to give it a try and find out yourself. It's very easy. And that will be all from my side. And I will pass the voice to Piotr, who will tell you more about the computer use.
Hello, everyone. As Konrad mentioned, I will be talking about computer use solutions. Let me start with a reminder of the agenda on my part. First, it will be introduction to OpenAI. I will be mostly focusing on OpenAI solution with some elements of Anthropic, computer use agent. Then I will share some challenges and tips, show you a demonstration of Anthropic solution, and in the end, I will show you and talk through benchmark on those agents. So first, let me start with comparing those two, browser use against computer use. With browser use, we are focusing mostly on browser interactions, while with computer use, we have to we want our agents to perform any action on this PC, right? Also on abstract level, the difference is that what is coming into the browser use is, of course, screenshot, but also a lot of HTML data, the structure of the web page. On the other end, computer use has to work on the pure screenshot, the GUI perception of what is happening in the environment. Also, what is the difference between those two is that browser has limited possibility set of browser is focusing only on browser operations like clicking, typing text, while in case of platform-specific tools, we have access to all. In case of computers, we have access to all tools related to this environment. We have also to remember about the security difference. It's totally different between browser and the full access to our PC. Okay, so let's start with a review of the computer use model for OpenAI. You can know it since a month ago. Our business colleague Alan had talked about the different OpenAI tools. Today, of course, I will dive a little bit deeper into this topic. So let's start with this table. The reasoning is average. We needed to have some information, some output from the model to see what was the decision making what was the decision making to perform the action. In terms of speed, it's considered slow. From my experience, it's 5 to 10 seconds for one iteration of the loop. It's quite slow. With the price between 03 mini and 4.0, it's not that expensive when we are looking at the text tokens. But with my work, I have noticed that the real cost of the input processing, the screenshot processing, can be much, much higher in the end. So let's take a look at the loop of this agentic system. We have our, on the left, we have our computer environment. It's our, in example, our Mac computer. And we are sending a screenshot of the environment, of the whole screen, into computer use agent model. Then the model is processing this image, and what is the output of such a model is the action. We have to be able to use this action to translate it to real action in our environment, and then again we are repeating this operation with action performed. We are making another screenshot that is sent to the model, and then after the action previously requested is performed, it can continue with its logic. In terms of how it looks, on the left you can see this request. What is important is to in this request, those are very similar to standard OpenAI OpenAI API requests and responses. And on the left, you can see that we have to think about our environment, about the display width and height, the resolution. Environment can be browser, but can be also Mac, Ubuntu, and Windows. And we are in the body of this request, we are sending, for the first time, we are sending the usually text, the task of what we want to achieve with this agent. And in the next loops, as said, we are sending screenshots. In terms of response, we have two most important parts of it. First is output, where we can find our action requested by a model. And then there is reasoning, so all the logic behind the decision. Let's quickly take a look on the list of OpenAI actions. Most basic actions are, of course, screenshot and wait. Screenshot, of course, to make the copy of our GUI for the model to make the reasoning and make the decision on the next action. We have action wait. It's also very common since sometimes the action can take some time. So model want to wait for the action to achieve its goal, and just then continue with its work. Action click and double click are pretty standard. In example with Anthropics, we have here we have action click with button left or right as argument. Anthropic has three separate action: left click, right click, and middle click. Others are pretty standard everywhere else. Okay. So during my work with the computer use, I had following challenges that very often my agent didn't want to start application written down. I asked it to open calculator to make some actions. It had problem with opening it. So the solution here was to add the application to the toolbar. So it was part of the screenshot. It knew how to open this application. Or another solution was to expand prompt. So the instruction had information how to get into one of those applications. Very often, also the issue on my end was that for the screenshot sent, OpenAI model didn't want to perform any action. It was raising the safety error, and it was related to some elements of this of the screenshot. So the solution to repeatedly occurring of this issue was to run all of applications in the full screen. So the screenshot was mostly only the application. Also, very often the model was asking me question: should I really open this browser? Should I do this or that? So the solutions here was to, in example, or the improved prompt to ensure it. Yes, you can do this to perform search use Firefox browser, but we can also make it as human in loop operation where we are answering in real life those questions for the model. One very big tip on my end is to use virtual machines, because in this case the screenshot is always stable. If I run one agent and one of my colleagues run the same agent on a different machine, we might have totally different actions because elements of desktop or of the screen can be are different between the versions of systems of computer, right? So it's important to have the stable environment. Also, I think is nice thing is to limit our request count. As said, it's generating costs, but it can also block a little bit the system since it's getting control over everything. And that's why I also think that logging into separate file is important, because sometimes we don't see what is exactly performing, and the environment might be closed. We might want to first close the environment because it's not responding to us at all. So logging to the file is providing us with stable output from the whole process. Okay, so let me quickly show you the demonstration of the Anthropic solution. What you can see, it's Streamlit application with a virtual environment on the right side, and on the left side, we can see the chat with our model. I have put at the beginning a set of instructions. to perform in this virtual environment. And since then, you can see that from time to time we have the screenshot and the message from model with reasoning, and then action what it wants to perform inside this environment. Operation here is quite simple. It's adding 5 to 10 and multiplying it by 3, but it shows the capabilities of this model on such a simple task. You can see that it even divided the operation of writing down 10 to clicking 1 and then 0, right? Those actions of those models can be really interesting. Okay, and I can tell you that it's achieving its success, not using brackets, right? Like we could perform this operation. It's using equation sign to get first result and then to get another result by another operation. And with last multiplying, we get the result. Yes. Okay. As promised, in the end, is the benchmark, time for benchmark. Previously, I have showed you simple task, calculator, right? But how does this model perform in terms of more complicated tasks? From my experience, harder tasks were also less. There was lesser chance to achieve a final goal. I want to share with you the view on OS Word benchmark. It consists of 369 tasks from 5 different areas, from sending email to slide editing, terminal commands, into even code assist. And what the score that you can see in this table is percentage of success rate. So you can even see that the best model in this benchmark is performing no more than 43% of success rate of all tasks. It's not a lot, because if we take a look at the browser benchmarks with similar tasks, but only focusing on browser using, it's more than 80% usually for the top performers. To sum up what I have shared with you today, well, computer use solutions are still very in beta tests. They are quite expensive and quite slow. Their possibilities in terms of computers are quite limited right now. In terms of replaying scenarios, the trajectories, they are much harder to replay because the stability of the environment is very important. The elements can be in different spots on different computers. Also, I would say that I am expecting those solutions to develop. In the previous benchmark, you couldn't see Anthropic solution with Cloud 4. Maybe in next weeks we will see how it performs on those benchmark tasks. And if you want to check out yourself this kind of agentic applications, I recommend using Anthropic Computer Use Demo because it's very simple to start. This was the application I was showing in the demonstration, because it's with one command you have to export your Anthropic key, and with the second one you are running Docker application with everything set up. With this, I would like to thank you for coming, and that's all.